This video is to look at what effect terminators have on a DMX signal. I've got a simple scope here, a $350 Rigol scope. We have a Lynx Express version 5. And we have a signal that's coming from this cable. And that signal is from a Lynx dongle. It's just simply outputting a keep alive signal right now. I have a Cat5 splitter, and that's simply hooked up to the scope. Now, let's just go ahead and look here at the scope. I'm going to just simply plug this in. Now, what we should be looking for is we should be looking for a nice, clean digital signal that comes down, goes up, over for a period of time, goes down, and then straight back out. Just nothing more than a square road bump. Now, what we can see here is that we have a nice rising edge. We've got a little bit of hop here at the top and a little bit more at the bottom here. So it's not coming off completely square like we want it. Now, let's do something real simple. What I've got here is I have a 220 ohm resistor that is simply hooked up to pins 1 and 2, which are the data signal lines. And we're just going to plug that in and see what effect that has. So we'll plug this in, and you can immediately see that there's a dramatic difference in the signal. You've got the top edge, you can see it just a little bit rise above and a little bit fall below. Now, one of the things you'll notice here is the voltage change. So here we're looking at a voltage roughly of about 5 volts. I take this out, now we're looking at 7.8 volts. So clearly the resistor is attenuating some of the signal, but in the process cleaning up the reflections and smoothing out the signal. So somewhere there we've got a balance of how much signal power we need and how clean we want the signal to be. So let's go ahead and take that out, and let's take this cable, which is from the DMX output, and we're going to plug it in over here on the DMX input of the Lynx Express. Now, there are two outputs of a Lynx Express. There's DMX out, which is right next to the DMX in, and there's a DMX out 2. Now, DMX out 2 is a amplified or repeated split of the signal. It's not just simply the equivalent of this. The equivalent of this, which is signal comes in, we split off a copy for the Lynx Express and then go back out, is on DMX output, the first DMX output next to the DMX input. So let's go ahead and take a look at that. So the first thing we'll do, we've not got a terminator in here. Signal going through the Lynx Express again, same thing. 7.8 volts. We've got a little bit of a less than perfect signal here. Now, let's go ahead and do this. We can terminate it. We could terminate it here. We'll go ahead and plug a terminator in. You can see that cleans up the signal. Drops the voltage down to about 5 volts. Now, the Lynx Express also has a terminator. So we're going to go ahead and terminate this connection. And you can see that that results in the same result, but because this is a 120, I believe, ohm termination, we have a larger drop in voltage. In this case, it's right at 4 volts. Signal's nice and clean though, exceptionally clean. So let's go ahead and take that off. And let's go ahead and move the signal from the DMX output over to the DMX out 2. Now the DMX out 2 again is a repeated signal. So the signal comes into the Lynx Express, there's another 45 chip on here, over here. It simply repeats the signal, nice clean. It's not just copied. So we plug it in. We do not have termination on the Lynx Express, nor do we have termination in the signal in the splitter here. And you can see that we're sitting at about 5.2 volts. We've got a slight drop in the overall voltage coming out of the Lynx dongle, but the output signal is at 5.4, and it's relatively clean. Actually, I would say it's very clean. Now, let's go ahead and put a terminator on there and see what effect that has. So we'll plug the terminator in here. We get a drop to 4.2 volts, which is about what we saw when we put 120 or 100 ohm on the Lynx Express. Again, nice clean signal, no problems at all. Okay, what does that tell us? Well, it tells there's obviously a relationship with the number of items that we can put on the line. Each one of those items or loads from a DMX controller, such as, in this case, a DMX module we'll drop the signal some. And we're going to see in the next video a real-world example of where we have nearly 80 different, or over 80 devices on a single Cat5 cable strung across several hundred feet of cable. And we'll see what kind of voltage differences we get and what the signal looks like before and after we terminate it. Here we have the end of a run. This run goes down here, goes all the way to the end down there. There's about 5 or 6 feet of cable between each 32 of these. It then loops back around through each one of these white poles, back and forth, all through these white poles, all the way over here. And so we come down here and we have this wire. And what I've got is on each end, in the middle, at the end down there, we have a terminator. That terminator is 220 ohms, and the other end of it terminates right here. So, what I've got, you can see about 1.7 to 1.6 volts. So if we go, we can see 22, which is half of 44. So what I've got here, I'm just spliced into here. That's just hooked right up. Now if you look real closely, what you'll see is that there's a little bit of bounciness, not only towards the bottom, but you'll see that they're not very clean at the top of the rise there. So what I'm going to do, I'm going to plug this in. This is a 100 ohm, and we're going to see a drop. And you see how it cleaned it up a bit? See how it's not, especially down in here, right on the rising edge here. I'm going to pull it out. You can see the voltage jumps up by almost about 40%, but then we get a little bit of jiggling up here at the top. Just my observations for terminating DMX.